Uh, Welcome back. We are going to start the fourth unit today. Your fourth unit is all about your clustering. In this unit, we are going to study about your type of data, what we are going to use in clustering, and what are the different methods, properties, and everything we are going to learn in this unit. Now, first, let us talk about clustering. What do you mean by clustering? Clustering is, we have seen this in your previous sessions also when I was talking in your first unit about all your functionalities and everything. There we have seen about your clustering. What do you mean by this clustering? Clustering is you're finding the similarity of the data sets or similar groups is nothing but you all can see here cluster analysis. The process of grouping a set of physical or abstract objects into classes of similar objects is called as clustering. The example what I have given you, if you all can remember, I have vegetables and fruits together. So when I want to make it into small clusters, what do? I'll segregate all the vegetables one side and all the all the fruits one side. So this is nothing but your clustering. Now, a clustering is a collection of data objects that are similar to one another within the same cluster and as dissimilar to the objects in their cluster. The same example, whatever I've given, vegetables, all the veggies will be there in one cluster. All the fruits will be there in one cluster. Now, before going to your types of data in your cluster, first we have to know data structures. Now, you don't get back to your data structures of your stacks, queues and everything. Here we have data structures are two types. One is your data matrix. One is your dissimilarity matrix. Now, when I talk about data matrix, your data matrix is your n by p matrix. What do you mean by n by p matrix? In n by p, this is nothing but your rectangular matrix. So, here we'll be talking about basically the what are the similarities. The similarity things will come in your data matrix. You can see here, this represents n objects such as persons with p variables, also called measurements or attributes, such as age, height, weight, gender, and so on. The structure is in the form of relational table or n by p matrix. Now, here, as I told you, you have rows and columns as it is a matrix. So, your rows represents your real world entities and your columns represent the properties of that real world entities. For example, I will give you student information. Now, student information is nothing but the real world entity. Now, what are the columns? Now, properties of the student information may contain student ID, student first name, student last name, everything. So, this is nothing but a column representation. Now, when I'm talking about your dissimilarity matrix, your dissimilarity matrix is your n by n matrix. That is, it's a square matrix where rows and columns are equal. Here also you represent it in a form of a table or you represent it in your n by n matrix. Here all the diagonals would be zeros. If I take a 2 by 2 matrix, what would be my 2 by 2 matrix? 1, 2, 3, 4. So 1 and 4 are zeros. That is nothing but my diagonal representation. This is about your data structure. Next, coming to your types of data, in your clustering, we will study 4 different types of data. First one is interval variable. Next is binary variable. After that, we are going to study about your categorical variable. Next, the last one is your mixed variable. Coming up with your first one, interval scaled variables. Now, what do you mean by this? Interval. What do you mean by interval? Interval is nothing but 10 to 20 is an interval. 20 to 30 is an interval. So, we have particular range is nothing but the interval. And it is your continuous what? Numbering or your continuous scale. Anything we can call it as your interval. Now, after 10 to 20, what would be the next one? I need to get it as what? 20 to 30. Next, 30 to 40, like that. See, interval scale and variables are continuous measurements of a roughly linear scale. Examples are what? Weight and height, latitude and longitude. This all comes under your what? Interval. Then your weather, temperatures, everything. The measurement unit used can affect the clustering types and data in cluster analysis. How? See, I'll give you an example here. Now, basically, here I'll be talking about the individual data. In individual data, as I told you what intervals. But in individual data, do I have intervals? No, I don't have intervals. Now, for suppose if I take some scalings like 6 kgs, 3 pounds, 5 liters, something like this. So what I have to do? I have to do a data standardization. That is nothing but I need to convert this 6 kgs, 3 pounds, liters, everything into a standard data. Then only I can do this interval scaled variable. Now, for that standardized data, what I have to do, I need to find the absolute mean for that. Then only I can satisfy my interval scaled variables. This is about your interval scaled variables. Next, I'll be talking about your binary variables. What do you mean by binary? Binary is nothing but your zeros and ones. Everyone knows. Zero is what? Absent. One is what? Present. Generally, we use in that way. So, it's a two-state. One, two. What are the two states? See, a binary variable has two states, 0 and 1, where 0 means that the variable is absent, 1 means that the variable is present. Now, I will tell you an example here. Uh, uh, Before telling an example, I'll tell you about your two subtypes. What are they? Those are your symmetric and asymmetric. What do you mean by symmetric? Symmetric is I can change the values. For suppose, I'll take gender. In gender, I have female and male. Female, I'll be taking it as 1. Male, I'll be taking it as what? 0. Now, in symmetric, what can I do? I can exchange it. I can make female as 0 and male as 1. Yes or no? Now, when I'm talking about the asymmetric, what will be asymmetric does? Asymmetric is not same, not similar. See, I'll take an example of your COVID. When do we tell if a COVID positive patient is there? So what do we tell? The person is affected with COVID. If a person tested with COVID negative, then what do we say? He is not having COVID. So how do I give that? A positive person will be given it as plus, a negative person will be given it as 0. Yes or no? Now, can I change it? The positive person can 0 and negative person? No, which is not possible. So, that is nothing but your asymmetric. You can see here. Given the variable smoker describing a patient, 1 indicates that the patient smokes and 0 indicates that the patient does not smoke. Treating binary variables as if they are interval scale can lead to misleading clustering results. Therefore, methods specific to binary data are necessary for computing your dissimilarities. This is about your binary variables. Next comes with your categorical variable. Categorical is nothing but what? It divides into different. See, a categorical variable is generalized by a binary variable. In that, it can take on more than two states. That is nothing but your categorical. Now, it can be categorized in two ways. What are the two ways? One is nominal, one is your ordinal variable. Now, what do you mean by nominal? It has no particular order to categorize. Whereas your ordinal variable, it has particular order to categorize. You all can take an example of your what question numbers or anything. That is what it's an ordinal because after first question only I can get second question. After second question I can get third question. When I'm talking about this precisely when I'm talking about your question paper. Now, what could be the example for your nominal variable? I can take the nominal variable as when you are answering the questions. You can write first question, then you can answer your 10th question, then you can go back and jump into your fifth question. So no particular order is there. That is nothing but your nominal and your ordinal. Here we denote it by what letters, symbols, or set of integers, whatever. We are easy for that. Next you have mixed variables. What do you mean by mixed variables? Mixed variables are it's a combination of different variables. It may be your categorical and your binary or your binary and your interval or your interval plus category, anything, any combination is called as your mixed variable. So till now what we have seen data structures. We have two types of data structures. One is about your data matrix and other one is your dissimilarity matrix. Then we have seen types of data. In types of data we have four types of data. One is interval variable, next is your binary variable, next is your categorical variable and your mixed variable. Now, the next is about your properties of your cluster. Now, by seeing this, what are the properties? First thing is when I'm talking about clustering, clustering is your unsupervised. There is nothing but your unstructured. So that might be one of the property. Then when I am checking with all this, all the algorithms can use different types of data. Yes, these are some of the properties. Now, what are the properties? Your clustering scalability, yes. because I can use different data sets. Next, algorithm usability with multiple types of data, as I told you. Next, dealing with unstructured data. Yes. Next is your interoperability. So this four are your properties of your clustering. This is all about your introduction of the clustering. Thank you.